If you want to integrate some AI features into your .NET applications like Semantic Search or RAG, then you're going to need a vector database. And Amazon Web Services just came out with S3 vectors. I'm going to explore it in this video, and I'll show you how you can use it to store vectors and perform semantic search. So what is Amazon S3 vectors? It's basically a storage backend built on top of S3 that specializes in storing vectors and allowing you to query these vectors at scale. Now, before continuing, I also want to say a huge thank you to AWS for sponsoring this video and letting me share these cutting-edge features like S3 vectors with the .NET community. Now, here's my plan for this video. I first want to explain how we can use S3 vectors to do something like semantic search or RAG. Then I'm going to briefly discuss the pricing for this new service and what it offers, and then I'll show you how you can use S3 vectors from a .NET application, and you'll be surprised how easy everything is and how smooth it all works. But first, let's go to the drawing board. So what is the flow going to look like when working with S3 vectors? So let's say we've got some documents, and we always start with some form of data. So this is going to be step number 1. I'm going to denote it as data. Then we need to turn this data into vectors or vector embeddings. Embeddings basically represent a floating point representation of this data, and they can be used to perform vector search. Now, this involves some pretty complicated math that I don't want to explain as part of this video, but the essence is we're going to leverage a large language model, or AI, to generate these embeddings. Now, here we can use something like Amazon Bedrock, which gives us access to foundational AI models. So we have our data, and then we're going to pass this data along to an embedding model. So let's call this the embedding model. These are specialized AI models that can take in some data and convert it into a vector embedding. So this is going to be step number 3. This is going to represent vector data. So our embedding model takes in the data that we have and it generates the vector data or the vector embeddings. Now vectors are basically just arrays of numbers. So I'm going to represent this like, let's say 0.123, 0. whatever. So this is the format that we are looking for. And these can be pretty long and complex arrays of numbers. And this is where S3 vectors comes in. So step number 4 is going to be store vectors. Now, typically you would want to use some sort of specialized database to work with vectors. However, as of recently, with the release of S3 vectors, you can just use S3. But that's not the only piece of the puzzle. Then we need some sort of way to index this data. And this is where the magic happens. And S3 has this capability. So then S3 is going to create a vector index, and this is what allows us to perform vector search. And then the next thing would be having our user, which is going to input some sort of query. For example, let's say they input something like an article about modular monoliths. With typical search approaches like full text search, a query like this wouldn't give you any results. But with vector search, you can send a query like this with the prerequisite that you also have to pass it through the same embedding model to generate a vector first, then you can then use inside of a vector index. So I'm going to demonstrate this entire flow in practice, but let's briefly discuss the pricing for S3 vectors. So if you go into the pricing page for S3 and then navigate to vectors, you can see that the claim is up to 90% lower cost for working with vectors. Now if I scroll down and select a region, you can start seeing some numbers, and essentially the bulk of the cost is going to be in your put requests when you are storing the vectors inside of S3. It's going to cost you 0.2 cents per gigabyte with a minimum charge of 128 kilobytes per put request, but of course you can batch this to upload multiple documents. Get list and all other requests are charged at 0.055 cents per 1000 requests. So then you can take into account your scale and see if this makes sense for you. Now this is just for storage. You want to also query your vectors, and here you have to pay 0.0025 cents per 1000 requests, and then there is some additional cost for passing along the vector data. So that's about the pricing. You can see an example here of what that would look like. I'm going to leave the link to this page in the description of this video so you can explore it further and figure out roughly how much this could cost you if you want to use S3 as your vector store. Now let's go into the AWS console, and from here we're going to navigate to S3, and then if you go to the left you can find vector buckets. Now this is currently in preview, but nonetheless we're going to use it. The user experience in the console itself is pretty limited. All you can do currently is create a vector bucket. So let's give our vector bucket a name. I'm going to call it MJ Tech articles. I'm going to leave encryption with the default option and create my bucket. And then the next thing I want to do is go inside of my bucket and create a vector index. Now, what's important here, other than the index name, because you're going to be using it when uploading a vector or when performing a vector search. So let's start by giving our vector index a name. So I'm going to say article content, and this is descriptive enough for me to understand what this index is indexing. And then the next thing you want to input is the number of dimensions that you want to use for your vector. This basically represents how many elements your vector or the embedding contains. This is going to depend on the large language model that you're using. I'm going to use a model that has 1024 dimensions, so I'm going to input that in the dimension field. Then the next thing is the distance metric, and this just determines which algorithm will be used to compare two vectors when doing similarity search. You can do cosine or Euclidean. Again, this is a bit of complex math. I'm going to leave some useful documentation links in the description of this video as well. The next thing you can do has to do with metadata. Now, when you upload your vector into S3 vectors, you can pass along any metadata. And by default, all the metadata that you pass is filterable, which means you can filter your data and also do a vector search. Now, this just allows you to specify which metadata is non-filterable. I won't be using this, so let's go ahead and create my vector index with 1024 dimensions, and let's use cosine as the distance metric. So let's create the index, and that's it. Now, all I have to do is take some data, generate some embeddings, and upload my data into my vector index so I can perform vector search on the contents of this data. Now, another thing I want to show you before we jump into the code is let's head over to Amazon Bedrock. I'll be using this service to access an embeddings model. And if you go into the model catalog, you can apply a filter to find models that are specialized in embeddings. I'll be using Titan Text Embeddings version 2. And what I want to show you here is the model ID, which you can use to connect to this model from your code, as well as the number of dimensions. And by default, this is going to be 1024, although you can customize this if you need fewer dimensions. I'll be using the default value, so nothing to change here, but note the model ID. We're going to need this inside of our code. Now, I did cover Amazon Bedrock in a previous video. I'm going to leave the link to that in the description of this video as well. So finally, let's jump into our application and write some code. Here's the baseline setup that I have. This is a console application with a couple of libraries installed. So let me show you what I have installed as far as the NuGet packages are concerned. So I'm using the AWS SDK Bedrock runtime so that I can use the AI models offered by Bedrock. And I already told you which model I want to use for generating the embeddings. Then I have the AWS SDK for S3 vectors. This contains all of the operations that you might need for managing your buckets, your indexes, and also uploading your vectors and performing vector search. Then I'll use Semantic Kernel, which is a nice abstraction layer from Microsoft that allows me to easily work with large language models. And then I have a couple of utility libraries that just make the code a bit simpler. So as far as the setup goes, I'm adding the iAmazon S3 vector service into the DI container. I'm also adding a Bedrock embedding generator, and this allows me to use an iEmbedding generator abstraction to generate my embeddings. You'll see what this looks like in just a moment. And then this part here is Semantic Kernel setup. Now, the essence of this is going to be a blog service, which accepts a URL to some blog posts, fetches that URL using an HTTP client, and then is going to try to extract the article content. Now, I specialize this to the articles on my website, and I have a document here that contains the links to all of the articles that I've written on my blog so far. You can see I have 156 articles at the moment of recording this video. So that's about 3 years of work of posting one article per week. And by the way, why don't you go ahead and sign up for the .NET Weekly? The link to that is going to be in the pinned comment right under this video. So going back to the code, what I want to do is iterate over all of the lines in this text document, extract the contents for that article, then generate an embedding for the contents, and then store that inside of S3 vectors. We're going to do that for all of the 156 articles, and then we're going to try to do a vector search and see what results we get back. So as I said, the model I'll be using is Amazon Titan Embed Text v2, and this is the model ID that I copied from the model catalog. And now let's start writing some interesting code. So I'll need a couple of services. First, let's resolve the kernel from my application services. I'll say app services, get required service, and let's resolve the kernel. I'll use the kernel to get an embedding generator instance, and I can do this by saying kernel services get required service, and the service we are looking for is an iEmbedding generator. This is an abstraction from Amy AI or Microsoft Extensions AI, and what we want to do is specify two generic arguments here. The first one is what we are going to be using for creating the embeddings. I'll pass in just a string representing the contents of my article, and the result is going to be an embedding of floats. By default, most vector databases are going to use floating point numbers for representing vector data. If you pass in a higher precision value, it's going to be truncated into just a float, so be mindful of that. So then I'm going to resolve the block service. And finally, I need the S3 vectors. I'll say app services get required service, and let's specify iAmazon S3 vectors. So now I have all the services I need. So then what's the plan? The plan is to first extract all articles from my file. Then we want to generate an embedding for each article. After we have an embedding, we want to upload the vector to S3. And finally, once we've uploaded all of the vectors, we want to perform a similarity search. So how do we extract all the articles from the file? Well, this is as simple as file read all lines, and this already gives me back an array that I can iterate over, and the file name is sitemap_urls.txt. So let's iterate over this in a for each loop, and this gives me an article URL. So this brings us to step number 2, where we have to generate an embedding for each article. So I'm going to use the block service to get the block contents. As I said, I'll be doing some updates on the block contents to extract the relevant parts, but this isn't too interesting. And then we can create an embedding using the embedding generator, and we have to call generate async and pass in the article content. What we get back is an embedding of floats, and then we can use this embedding to access the vector, which contains the actual array of these floating point numbers. So to start out, let's just print this out to the console. I'll say console write line, and let's write out embedding vector. I'll have to call to array, and then we can, for example, say string join, pass in all these values and just connect them with a comma. And to make it more obvious that this is an array, I'm going to specify it in brackets. So let's go ahead and start this, and I'll just let the program execute. And this should start accessing the contents of my website. And you can see we're getting a bunch of numbers in the console. So these represent our vector embeddings. So I'm going to stop it here, and let's look at a practical example. I'm going to full screen this, and then you can see what a vector embedding looks like. So it's just an array of numbers, but it encodes the semantic information about the content that you are generating an embedding for. So the large language model is going to find the relevant information from my article and turn that into some numbers that I can do a search on. So let's comment this out and then move on to the next step, which is uploading my vector to S3. So this is going to look like a typical request to any AWS service. You create some sort of request object, and in our case, this is going to be a put vector request. So what can we input here? Well, we have to specify the vector bucket name, and the bucket name is MJTech articles. Then I'll specify the index name, which is article content, and then we have to specify our vectors. Now, it would be more efficient if I were to generate all the vectors upfront and then input them in a single request. So let's go ahead and do that. I'm going to drop the request below the for each loop. And here I'm going to create a list, which is going to contain a tuple representing the URL of the article, and then a floating point array representing the embeddings. So let's call this the embeddings. I'll initialize it as an empty list. And after we generate an embedding, we're going to add it to the list. So let's add the URL, and then I'll access the embeddings vector, and then I'll say to array. I just need to replace this with article URL, and then this should be fine. So then we need to initialize the put vectors request. So this is going to be a list of put input vectors. So I'll say embeddings, and then let's select, and we want to turn each of these embeddings into a new put input vector. And what do we have here? Well, here we can specify the key that is going to uniquely identify this object, and we can also pass in the vector data. So let's specify a key. I'll say article, and then let's randomly generate this using a GUID. I'll say GUID, new GUID. So that's my key. Then we need to specify the vector data. So here I can just say new vector data and then set the float for the to value. And I want to access my embeddings, and I just need to pass along my embeddings in the list. Then I have to call toList here, and this should finally stop complaining. And one more thing you can pass in is any metadata you want to additionally store with this object. And for me, this is going to be the article URL, because I need to be able to retrieve this to display it in my semantic search results. So the API for this is a bit cumbersome. You have to initialize a new document and then a new dictionary inside, and then you can specify your key value pairs. So my pairs are going to be URL, and then I'll specify the URL value here, and this constitutes my put vectors request. Now, sending this request is simple. You just say S3 vectors put vectors async, and you specify the request. We're going to get back a response object, and let's go ahead and do a console write line after we get the response. And let's say I want to write the HTTP status code. So now I'm going to start my application, and I'll place a breakpoint here. So this might take a couple of moments because I have to process a bunch of documents and generate an embedding for them. So I'm going to speed this up and jump to the point where all of the embeddings are ready to be stored inside of S3 vectors. So after about a minute, I have all of my embeddings ready. You can see I have 156 of them, and inside of each tuple here, I have the URL for the article and the respective embeddings in a floating point array. So then I can initialize my put vectors request into the index that I want to use for these vectors, and let's go ahead and create a request, and I'll send this request to S3. This should hopefully complete fairly quickly, and we get back a response, and the status code is 200. Okay, so this is awesome. I've managed to upload the files into S3. So I'm going to temporarily add a continue statement here so that we don't end up generating the embeddings. And I'll comment out the request here so that I don't send this to S3 because we already have the embeddings. And finally, let's see how we can perform a similarity search. So first thing first, we need some sort of search term. And in case of a semantic search, this can be anything. And as I said, I want to look for an article about modular monoliths. So this is going to be my search term. The next thing I need to do is to generate a search embedding. So we have to say embedding generator, generate async, and we pass in the search term to get back an embedding. Now it's important that you use the same exact model for generating the embeddings that you use when uploading to S3 vectors, otherwise none of this is going to work. So in our case, this is just going to work fine. And then I need to initialize a new request object, and let's say this is a search request, or better yet, this is a query request, and I need a new query vectors request. So here we can specify the arguments for our vector search. I'll specify the same bucket and the same index. You can turn on return distance to get back the distance for each element, which represents the distance between the search term vector and the vector you have stored inside of S3 vectors. Then I'll say return metadata as true. These are both false by default. You can say top K to determine how many search results you want to get back from your vector search. And the lower this number is, the faster the search is going to work in general, because vector search usually works with an approximation to make the search operation faster instead of looking at all of the vectors. I am not currently aware if it's possible to configure this when working with S3 vectors, but I suspect this should be added at some point in the future. Another thing you can specify is the filter, which allows you to filter on the metadata. I won't be needing this. And finally, the last thing we need is a query vector. Let's initialize a new vector data object and pass in the vector array. And here we have to say search embedding vector and pass in the embedding for our search term. So now we have a request. Let's add a response object. I'll say S3 vectors. We'll say query vectors async, pass in the query request object, and then let's see what we get in the response. So the response is a query vectors response, and inside of it, you can find the vectors array. So let's use that. I'm going to iterate over this. So let's say result vectors. I actually messed this up. There should be response vectors. And then the type that S3 uses is an output vector. So let's call it that. And then I can use the output vector to print out some data in the console. And for example, I'll print out the output vector key, the distance from the original search term, and from the metadata, I'm going to pull out the URL value. So let's add a breakpoint here. I'll start my application and we hit this breakpoint. So the first thing we do is generate a search embedding. Remember that we are using a large language model from Amazon Bedrock to do this, and we get back a vector containing 1024 dimensions. So now I initialize a query vectors request, where the key part is an index that we previously populated with our vectors. So now I can send this request to S3. We get back a response. You can see the HTTP status code is 200 OK, and I can iterate over the vectors. And if we take a look at the result in the console, you can see the top 5 results are my articles about what is a modular monolith communication patterns, modular monolith data isolation, monolith to microservices, and then testing modular monoliths. For each of the URLs here, you can see the distance from our search term. And basically, as the distance increases, these search terms are ranked lower and lower in terms of relevance. If I try try this with a different search term, let's say an article about CQRS, and let's rerun this. Inside of the console, we should see the top 5 results, and the first one is Stop Conflating CQRS and Mediator, and then we have a few other articles where I mentioned CQRS. So that's how you can use Esprit vectors as a vector database inside of .NET using the AWS SDK and Amazon Bedrock for generating the embeddings. You can see this isn't really a lot of code, so it's awesome that we have these good abstractions that allow us to build some pretty complex application features inside of our applications. If you want to grab the complete source code for this video, you can do that by checking out the pinned comment that's going to be right below this video. And if you're new to working with AI, large language models, or semantic kernel, I highly recommend that you check out this video next, where I'll give you a beginner-friendly introduction using Amazon Bedrock. If you want to grab the complete source code for this video for free, you can do that using the link that's going to be in the pinned comment right below. Make sure to smash the like button on your way out. Thanks again for watching this video, and until next time, stay awesome.